Hello everyone, I'm so glad to introduce our work, Adversarial Alignment for Source-Free Object Detection for you. This is the joint work from Chaosong Chu, Shuyan Li, Guangyi Chen, Kai Li, and Xiu Li. While deep object detection methods have achieved promising performance, they assume that the testing data and training data are drawn from identical distribution. However, in real-world scenarios, when the detector faces a new environment with huge domain shift, significant performance drop will occur. On the other hand, manual labels are expensive to obtain for every ad hoc target domain. It requires detectors to efficiently adapt to new environments without further annotations. In the absence of label data from the target domain, unsupervised domain adaptation detection methods have emerged to mitigate the domain shift in data distributions. Conventional methods are based on the assumption that both source and target domain data are accessible. However, due to the data privacy and the efficiency of data transmission, we may not have the access to the source data. What we have is just a detector pre-trained on the source domain. A straightforward way is to use the source pre-trained detector to generate the pseudo-labels for target domain optimization. However, the domain shift inevitably introduces high noises in the pseudo-labels, which deteriorates the detection performance. The source pre-trained knowledge is difficult to adapt to these samples, which are far dissimilar with the source data. While aligning source and target domain is widely used to improve the quality of pseudo-labels, the lack of source data poses a new challenge for domain alignment. To solve this problem, we separate the target domain data into source-similar ones and dissimilar ones, on assumption that there is distribution overlapping between source and target domains. We drive the source dissimilar features close to the source similar ones, such that pseudo-labels generated from the source pre-trained model are of high quality over the whole target domain. To achieve this, we design a variance-based criterion for the target domain division. Although we have no access to source data, the source pre-trained model does convey rich information about the source domain. As we find that larger detection variance denote higher similarities to the source data, we calculate the detection variance based on predictions yielded by the source pre-trained model as the target division criterion. We qualitatively show that the pre-trained model tends to yield more predictions of hard objects in source-similar images, while directly ignore these hard objects in source-dissimilar images. These predictions of hard objects usually have high uncertainty and hence have larger variances during adaptation. We conduct multi-color sampling for predictions with dropout to approximate the detection variance. We consider target images as source-similar with prediction variances larger than a predefined threshold, and consider the remaining ones as dissimilar. Our training framework contains 4 stages. Firstly, we pre-train the detector with the source data. Secondly, we perform target self-division to divide target data into source-similar and source-dissimilar using the pre-trained model. In the third stage, we align source-similar and source-dissimilar data via adversarial learning. Finally, we further fine-tune the model to reduce false negatives. We conduct experiments on 5 popular object detection datasets to evaluate our method. We compared our proposed method with SOTA methods in the following adaptation circumstances: adaptation from normal to foggy weather, adaptation to unseen new scenes, adaptation from synthetic to real images, and adaptation to large-scale dataset. It shows that our method achieves the best performance in above-mentioned circumstances. In the ablation study, we evaluated each component of our proposed method. You can find more details in our paper, and we have released our code for you better understanding our work. If you have further questions, feel free to contact us. Thank you for your listening.